So we start with the first panel, Edge AI for 6G networks. So the general idea of Edge AI for 6G networks is to design an hierarchical AI system where a large model in the cloud is responsible for generating, selecting, and managing a library of small models that are deployed at the edge for real-time operation. So these small-sized models are capable of fast inference and a few-shot learning, allowing them to adapt quickly to local changes. Different models can be dynamically switched to handle small-scale variations in network conditions, while the cloud, equipped with broader general knowledge, can generate appropriate baseline models based on the general network conditions. So this connected and hierarchical edge AI architecture should allow edge devices to sustain high performance by leveraging centralized intelligence, even under stringent resource constraints. So for this panel, we have 4 related questions. So we start the first one. How can we balance the performance with edge device resource constraints? So anyone would like to start?
So perhaps just to break the ice, and a question from an outsider that I've mentioned yesterday, I'm really not a AI contributor myself individually, but I do keep a very keen interest with all the potential for transversal disruption and transformation across multiple areas of our activities. To me, it's a little challenging to understand exactly as we put edge computing, we used to call it only a few years ago, let's say now AI, ML, compute power at the edge. So historically, we've had this layer approach where physical layer, whether we like it or not, is treated as perhaps a very fancy pipe, but a pipe. And we don't dive into the content, regardless of courageous efforts with the MPLS and other ways of doing deep packet inspection. It never really has taken off to dive into the packet content and do any content-specific processing whatsoever. So then at the endpoints, the server, the client, they deal with the application at the software level, and they do whatever they need to do, almost oblivious to what the physical layer is doing. Now, in order to do AI at the edge, do we have to break that model? How does the edge knows that the packet is just doing a very simple, trivial, internet processing or data transfer of whatever kind, or even a phone call for that matter, versus needed to invoke fancy AI ML processing? How does that work? Do we need to break that pipe versus app dichotomy?
Can I do it? I think the question here is more of a cloud computing and orchestration of applications over cloud computing, except that when you bring in the edge, you've distributed your infrastructure. So now you're not talking about a core cloud that's distant, a near edge that maybe like where a CO is, and other computing equipment that may be near, including the end user device. Now, what you do have is you have a kind of progression of compute power and cost trade-off as you move more into the core and out. Now, one extreme is the one you were referring to, which is just deploying an AI application, let's say for inference, at the edge. And there, you're going to be limited by the compute resources of whatever gear you have available. But an alternative to that speaks to the balancing is to use distributed orchestration implementations of the AI application. And for example, one of the things that some of my students have done, you'll take the monolithic code of a large model, and you have the means to, you take that code, break it into pieces, and then you have a optimization code that looks at how to optimally deploy it across this continuum while balancing cost, latency, and volume of information that needs to be transferred. So it's more than
Yeah, I
a
think
layer question, I think.
I understand the concept of taking the cloud and spreading it all over towards the edge. And I think a couple of years ago, we used to talk about fog versus cloud.
Yeah.
But that still retains the pipe concept. Now, if the pipe traffic is demanding at the higher layer, at the up layer, some cloud assist, then whether it's done on a concentrated point of a number of cloud servers or even the edge server, I can understand that. But let's say I'm on my cell phone and I'm doing something very trivial like show me the nearest restaurant. And that's not need AI. It's a very simple query versus I'm asking something more complicated that does need AI help, assist. At what point and what protocols are then engaged to answer the question whether I'm just looking at as I said, a very simple transfer, no AI involved, or there is AI involved, and now I involve whether the widespread cloud or even the edge cloud. I think it demands looking at the packet content, which gives me concern that we've never been able to do processing that is content specific.
I would say that the choice of communications pipe or whatever you want to call it depends on the application that you're working. Users don't work directly with the lower layers. They work through a port number of some sort. Okay, yeah. But so the going into the content is not necessary from the point of view of the applications. Not usually.
I think we have activity now, so I'll go back to the background a little bit.
I think, Ronaldo, you're still thinking in the ways of AI that we use today. And I always say, if we do text prompting today, it's like SMS in 2G. Then what we do now is, I at least do that, if I want to change like my heating system, something in the room, I just upload a 168-page PDF, ask my large language model for an answer, and it comes beautifully back with exactly what I need to do. I don't have to read a manual anymore. That file transmission, that's 6G. No, that's 3G. So that's exactly what 3G was. We did file, email, whatever transmission with our BlackBerries and things like that. Now, if you're talking about video prompting, that's the next stage. That's going to be happening in the next years. We're going to upload video snippets and ask it to come back with some kind of a video for us. And after video prompting comes real 3D capture motion prompting, where we can really, in real time, interact with systems. Now, if you think along that line, we're going to need way more compute than we have in an edge device. But we need some capturing AI sitting in the edge device. And we have to have a mixture of experts sitting in the cloud. I mean, I always say that, take the most famous ornithologist. He's at the Lake of Constance with a big database on bird migration. You're not going to put that into some large language model. That's going to be a large language model locally available, however, in the cloud. And other kind of things, like for travel, for this, for that. So we will have multiple experts sitting all over planet Earth. And you need some orchestration middleware to be able to take your prompt and ask exactly, pose it in the right way to ask the other expert that are sitting in the background. And so, at least that's my view, we will have at least 3 layers. We will have the layer sitting in the device. We will be having the layer sitting at the mobile edge, which is not what we're talking about here. These are edge devices, but the mobile edge. And there we can think of like the base station of the future, RNCs of the future, that will be having a lot of AI compute anyhow to do the physical layer you were talking about. But on top of that, can make this available for the other AI inference engines that we're going to have. And then we have the large language model sitting in the background. And this, I think, Alberto, that's sort of trying to capture what you're saying. So it's not so much about the physical layer, it's about trying to understand what's going to be happening. And this is just prompting. This is not even general AI or anything or super intelligence as people are projecting.
Yeah, I will just follow the Renato trends of discussion. The question here is, yes, the edge computing today is not reality. Because when we do the EMBB service, the OTT is a super strong. The carrier or anybody in the edge cannot compete because they don't have any app generation and value to deliver, and the over the top can manage to have use the bandwidth efficiently in different their coding format, and they don't need to go through any like a standardization that process, so they are managed successfully up to today. Even not very massively that edge computing is deployed. AI, I think it will be different. So because the nature of Gerhard mentioned this thing, so there will be a certain AI computing in the edge. Now, so I'm with Renato is that because the site power is limited. Anyway, it won't be a nuclear power on every edge. That will be millions of nuclear generators. So once the power is limited, the computing power we spend on the compute AI or compute what already optimized connectivity. So that's what I think I was with what Renato was saying. So I think the AI to get into further to compute the physical layer, compute the connectivity elements, and there so far we don't see any benefit yet. So once there will be AI computing, they should be compute more tokens rather than compute more bits.
Thank you. Thank you. So I think in my view, I see that, and maybe similar to what Gerhard has said, is that I can see potentially the new architecture is going to have kind of like some type of a vertical architecture where we're going to see definitely the cloud, we're going to see the edge, and we're going to see things at the devices, and there will be a combination. Having said that, I think I hope most of us would agree that the cloud has some limitations in a way, and edge, basically edge AI in this context can actually address some of these limitations. And I think it depends also on the applications. So for example, for application that requires ultra-low latencies, maybe real-time decision processing or making, and in this context, I think edge AI can be very important. So take, for example, IOV, for example, take the industrial IoT. Some of these probably having something at the edge can make a big difference. Now, in terms of trying to answer some of the questions, obviously, when we here, because I think we're talking about the edge devices, right? And clearly, this is an issue because they are definitely have, as you said, resource constraints. So I just want to mention two things that we have been working on in order to deal with this particular issue. The first one is related to what I refer to as pruning and quantization. So specifically, when you look at the model, basically you try to somehow, through pruning, try to remove or redundant parameters. So that's one way, for example, to make things better. But at the same time, we also try to deal with the computational complexity or perhaps reduce the numerical precision. And this can be done basically through quantization by trying to shrink the model size. So that's something that many people are working on, and we try to do that in order to deal with these edge device resource constraint. The other thing that also we've been working on is something related to what I refer to as knowledge distillation. So somehow imagine you have a very large complex model, very big with a lot of parameters. We call it the teacher model. And then somehow we try to transfer that knowledge from the teacher model to what we call a smaller model, we call the student model. And this is what, and then we're going to allow this smaller teacher model to be trained, and basically with much smaller number of parameters, with the hope that we can achieve the same level of accuracy. So this is also an area that a lot of people have been working on, and these are two potential solutions, the pruning, quantization, as well as knowledge distillation.
So if I may insist a little bit, let's take kind of a visual of the architecture. In the current setup, I am in my cell phone and I want to do some trivial connection to an app. The physical layer up to layer 3 establish a pipe into the RAN, and from the RAN I'm in the wide open internet, I do whatever, right? And the service provider establishes, maintains, and ensures that that pipe to the IP network is high performance. Now, if I want to do any app at the edge, it reminds me of the walled garden, when service providers wanted to own the app and own the user, and that never worked. That never worked. So if we treat AI as some form of app, how is it going to happen that if I'm going straight with my pipe into the internet access gateway, do I then come back to the edge to be AI servers, or is my traffic going to be intercepted at the edge? No, we do processing at the edge, like beamforming, right? So there is a lot of compute, and we do compute the weights of the beamformer, but this is all very physical layer oriented, and is very tight to provide a better pipe. Once we go higher level to the app level, I still have this problem that we've never been able to look into the content, process content by the pipe owner. Yeah. Now, I understand very well. I'm particularly involved in the future of my retirement is at stake. You know, if the pipe model continue being a pipe, there is a limiting growth as how many more pipes we can build. But that's a different story.
I think you can have. It's kind of a business type of question in the sense that as to whether it's a walled garden or not. It's a walled garden if you have no choice, where you have a restricted set of apps that are available to you, okay, in the edge. So that's going to run over some edge resources that are owned by some provider, okay? Now, there could be choices of providers in the near edge nearby or not. But let's suppose you have one provider along current service providers, you have your edge. But if you have choice in terms of what apps you want to use, and there are business arrangements, settlements, so that different providers of apps that are not associated with the service provider, if you have that openness, then it's not a walled garden, I would say.
But does it require at the edge that I dive into the packet content, open it up, understand the content so I can provide the right app?
Well,
that would break the current setup.
No, but there's some set of initialization procedures when you pick the app. Okay?
Yeah, we used to call it MPLS, and it was miserable death.
No, I'm talking at the app level. When you push here on some app, okay, that initiates
that requires
handshakes. That's going to go into there's some sort of server. Let's say with the local provider, but there's a broker that allows you to access whatever you like. There has to be payments of some sort, and then it sets it up. At no point do you have to dig into your content.
So you're saying at the session setup, or at the thread setup, there may be multiple threads in a session, but a given thread, depending on what I'm doing, I'm going to be initializing that thread, and in that there's going to be an interchange, and it's going to say this thread needs AI local, and then you pay this much to that provider, and then you continue without, okay.
It doesn't have to be AI, but yes.
Yeah, okay.
So I don't want to be, excuse me, I don't want to be a commercial here, but there's a former students at Stanford that have a company that's doing exactly what you guys are. It's called VecML, VECML, and they get, I barely understand a lot of this stuff, but these guys are ex-Microsoft and Baidu and so forth, and exactly the problems, and they have a product, and if you go to their webpage, it comes up like a chat GPT, but you can look around if you want to find out more information, or you can type questions
Yeah.
in. But it does exactly what you were just describing and breaking it up, the
Mm-hmm.
problem and optimizing it. So your specific, this retrieval augmented generation, which allows you to put a little database inside along with
Yeah.
the other, and then balance it across the net as to how much local storage and bandwidth that you need. So you might want to look there. I believe they're one of the more advanced groups in terms of this area.
Yeah, I think we probably we're not going to be able to use the 6G network to do all kind of AI service. That's like you competing with everyone in their whole domain. But what I think at least we can do is for certain specific services, which like AI type of services, which we can utilize take advantage of the operators' network infrastructure and utilize their capability to generate the data. That's why we were saying at least we start with intuitive sensing part. So we got our own data, which actually it's difficult maybe to get from the over-the-top guy. Then with that, you can actually utilize this capability, offer some unique services. We can start from there, then see what can expand. It's like we do the previously voice service, video service. We kind of have a way of looking into the data itself to know the contents there. So we're not genetically look at the traffic to understand the content. That I agree with you. It's difficult to do. But also, we even 5G days, we're trying to use this slicing concept so that each slice actually carries a particular type of services. This can be actually, I think we started with 5G, but we didn't have the tool to automate the generation of a slice. So we end up had to manually configure that. That is difficult to do. So we end up, make very big granularity. Say, okay, let's do this type of, EMBB slice, UIC slice. That's not sufficient. What we want to be able to is leverage today's AI technology, actually be able to automatically generate the customized. We call the generative network, a customized network to suit the individual services. Then in that case, that you can think about that virtual network is actually carries a particular service already. So that will allow you actually offer this kind of service without going into the trying to understand the contents itself. So I think we may have an opportunity there. Yeah.
Thank you. So, Rahim?
No, it's not so bad to be spending a long time and being in this area. Sometimes we need to rely on the experience that we have had from previous generation system. I don't know whether you remember in 3G time, Nokia had PDA, personal digital assistant, and at that time we were not talking about apps. And everybody said computing and all the processing of all this media in a phone, in PDA, is difficult, resource constraint, blah, 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 blah. And then Apple came up with the apps and icons that you don't need to do everything locally in a device. And it is over the top. So with AI, you can provide an intelligent user interface that everything that has to be done, computed locally. It can be done at the edge, so at the edge of the network or remote cloud or somewhere else. So it depends on the application side. So we need to probably rely on that experience that not everything has to be done explicitly the way it says. Everything has to be done at the mobile phone or UE or the edge. Different applications. And AI enables us to have that intelligent interface to remote processing, computation, and etc. So I would think that for the future applications, I think it will be something like app with a more intelligent user interface, AI enabled to do all this computing, either locally or remotely. Depends on the application.
Yeah. So I would like to echo Rahim's comment. Actually, when I see the question, I would like to start from the user scenarios. For example, for 6G users, so they depend on their specific requirement. For example, is that the smart factory, or just like the swarm of the drones, or just like the autonomous driving? Depending on different application, then as a user, I may want to get a package of different choices. For example, if we come to the specific scenario, so we say we can be given a package of, for example, the bandwidth, that is the resolution, the sensing range, or the power rating, etc. So that then the user can decide the different package, then ABCD, and then I can find the best one. So that is the balance of the power, the bandwidth, computer resources. But if we go back to the technical detail, how we can offer this package to the CG users, then we have to go to the detail. For example, previously we have discussed a lot about the green communication, the green base station technology. But now the AI plays a key role. On one hand, it can give the performance benefits. On the other hand, it costs the resources, power, memory, etc. So then we have to integrate the green communication and green AI, and then come to the different package to the user. Then the user will decide, depending on the mission.
Thank you. So now we move to the second question, which relate to the delay-sensitive applications. So how can we ensure real-time inference and the decision-making in latency-sensitive applications?
Yeah, I will start with this one. So if we need a GPT-3 or GPT-4 level of intelligence to handle that prompting, these are very big computing cluster and with some latency about over 100 milliseconds. So if that is the power intelligence we need with that latency, I think it will be all over the top. As Gerhard mentioned, you prompt your document because this is not time critical. You prompt your video, maybe. So these are likely will be over the top. So the time critical in the edge scenario, or the edge has some value added customization on the service that may, these are the two factors that will make the edge computing in terms of AI more make sense. But then there is depends on what AI will evolve. If it is regulatory of data in the country or in the region, then maybe those video prompt is will be limited in the edge. So it depends on the two. The latency is a performance factor, but then there are some other value-added service. What do you add more value compared to the superscalar, or do you have a regulation that you cannot actually share a lot of raw data to run the AI?
Great.
So what I really think is latency-sensitive applications in this case are the ones that do motion capture and motion control, and where you sort of are waving your hands and want to see some immediate reaction from either a video stream or a haptic device that you can touch, so a robot or whatever it is. And these kind of systems will not be able to provide the level of compute in the edge device, but there has to be compute sitting in the radio access network metal in the hardware there. And we will have, as I mentioned before, we will have AI acceleration in the base station equipments anyhow, just for the physical layer. So we have to beef it up such that we can run these bigger inference engines and that can be updated as the applications evolve and grow. Because we actually, honestly, I would not know what's going to be the killer app on that sense. We know it's going to be happening. I'm sure it's going to be big, but we have no clue at this point in time. For that, actually, we need not an LLM sitting somewhere in the cloud. It has to be really as close as possible. That is probably the time when we see this idea of mobile edge cloud actually evolving.
Yeah, thank you.
So let me just try one more time and then I give up. Isn't there a parallel with voice over IP versus voice over LTE, VoLTE? So it's very interesting that the cellular providers, of course, started with voice being the only service and then becoming the primary service to become eventually afterthought. So when LTE came out, there's no voice. And yet the over-the-top guys were giving us voice over IP. So as soon as you got, even in 3G, connection into the IP cloud through a gateway, you could do voice over IP. It took several improvements to the LTE to get to VoLTE. So this is what I'm talking about, pipes that are owned by the service provider versus pipes that are just wide open internet over the top. So it is my guess that a lot of AI, at least early generations, are going to rely on a dumb pipe, IP connection into the big cloud. And over-the-tops are going to be challenged with the latency, but with their power, they may do interesting tricks. Is the trick going to be as much as putting a over-the-top cloud compute at the edge? It sounds like you go there and then back, but I guess they can do some interesting tricks with routing so that the user data doesn't have to go do the U-turn and be processed locally for latency. At what point does the service provider has enough muscle to muscle themselves into this equation and participate in the revenue generating? I wish they can, but history tell me it's an upfight battle.
Yeah, John.
In some of the recent research we've been doing, we run into this problem in trying to solve like the scheduling problem with the physical layer. Where we know the solutions to, you can optimize that now. That wasn't known a few years ago, but the intensity of the computation involved to do that is very, very high. And so what you run into is this, how much do you split the computation, cloud and otherwise? And unfortunately, nobody really, whether it's the CPU or the GPU side, nobody's really got full solutions for this. If you actually look at it and try to do it, they're an order of magnitude off. And I know the GPUs cost more energy and so forth to do the same type of thing. But what's starting to emerge is this concept of the digital twin, where you have something back in the cloud, but it's really trying to take the data from the local environment, process that, reconstruct the situation, run through all the options. We were talking about the spatial as well as the time, identification of the channel with the sensing discussions yesterday. And I think there's a solution that emerges what Ronaldo's talking about, as well as the larger computational, large language models back in the cloud, so that the service provider will have to have some kind of policy capability. We talk about APIs, just that it will actually allow some level, some smaller level that's not too much power and so forth at the mobile edge to take advantage of policies that are derived from the digital twins, which may very well be heavy-duty computing with GPUs and so forth back in the network. And the exact split of that is hard to define, and a lot of pieces are still missing. When you look at certain types of software or optimizations, everybody says they got all this AI and that, and then you try to go do it. And there is nothing that solves the problem you need to have solved, or it's only on one side, it's a CPU side, and you want it on GPU side, or vice versa. So there's still a lot of work to be done, and the exact split is not there, but I do believe there's a strong position for both service provider as well as application provider, but also there's going to be a split between the custom accelerators and the GPUs and so forth, and some policy or interface And that's that openness of that interface and an ability to get into the service provider, allow the application provider to make the service provider more money, other than trying to control everything and do it themselves at that local point. And if it doesn't go that direction, I think everybody loses in the long run. It hasn't been that way yet, but I think it could go that direction, and that split and using the twins and the heavy-duty computation somewhere where you can pay for it or where you can actually implement it, and then finding all the edge cases and so forth so that you don't have the problems we're talking about where you get the silly answers out of AI and so forth yesterday.
Wei.
I think this question also remind me about the old signal processing problem. It's called in the physical layer is the quickest signal detection. So that means once you accumulate more and more signal, and then come to one critical time, you have to make a decision that is especially suitable for the latency sensitive communications. And if we come back to the edge AI, so then the key thing is that how we can get the useful and key feature of those data. So we cannot just use all the data to make the inference. That will take a long time. For example, the autonomous driving, so the camera will take all the surrounding environment, and those video data is quite huge. And then how we can just take the region of interest image. So that quite takes a small set of the data that may help us make the inference. And also, we want to make the quickest detection or quickest inference, then we wish that the data may not be huge. So we can use the sparse data. At the same time, we can use the GAN model to synthesize another set of data to augment this training and then make the inference quicker. So that is another possibility.
Rahim?
Go ahead.
Again, I just want to say that let's not make the same mistakes as we did in 5G. We talk about low latency, et cetera, and 10 times lower. And we need to look at the application. And most of the application I've seen, low latency, it doesn't mean 1 millisecond. It could be 10 milliseconds. It could be 5 milliseconds, depending on different applications. But more important thing is the jitter. Not only just the magnitude of it, can we maintain the jitter? And that is more important for when the end of the communication is a machine, is a robot, because people can absorb delays. They are more tolerant to that. And when we have machines or robots at the end of it, we have more computing capability in them than UE. So I would say, I used this term yesterday, but low latency, low jitter, real-time inference, etc. We need to look at it on a application basis, and we look at what capability is the other end of the communication, rather than it's not just UE device. I think Wei mentioned about autonomous driving. So we got in a car, we can have big computing and computation facility in the car to do all sorts of information and do real-time inference or decision-making. That's what.
So just on the jitter side, one quick comment. Because many people always talk about the low jitter. And I've been working with industrial control people, and they tell me zero problem. It's not a problem at all, because all I do is I add on the slack time that I'm allowed to do, and the jitter has to stay within, generate the maximum slack time. So that's just your outage probability event. So not that we go down that route again, thinking that jitter matters, because of course jitter does matter, but it's just something that you add to your max slack time, and then it's all about latency. So, but I do agree that latency is very different. If we're talking about voice, what you were talking about, it's 300 milliseconds. So who cares? That's not low latency. If we're talking video, it's like 50 or to 30 to 50 milliseconds. That's our interactive video. Beyond 30 milliseconds, you start noticing it. And that means what we see, and if you start really interacting with a touch and feel, then it goes below that. So it all depends upon the future applications. If it's all about voice, Ronaldo, then the 300 milliseconds is okay, and we can do everything somewhere in the cloud. But if it goes lower than 100 milliseconds, we need this edge layer, the orchestration layer you were talking about, Alberto.
Yeah, I think it's probably we all kind of agree that for low latency stuff, you have to push into the edge. The question is whether edge going to be provided by the operator versus by the cloud guy. They're also pushing the edge. So who's going to win? But I think I do think what John said, that they got to work together. Otherwise, nobody can win. Because even today, you look at the voice, is that VoIP? The whole reason we are using the VoIP, let's say we use messenger call, WeChat call, is because they have the safety net of operator will provide you sometimes in emergency you need this reliable voice call. So therefore, they can play with some unreliable things. And I'm not unreliable, it's working most of the time, but maybe not the remaining part. If we actually take away the voice support from the operator's network, see how can this provide a voice. It's going to be difficult as well. So it's easy to do the 80% of things. The remaining 20% is the problem. So I think we were actually quite, originally I was thinking the same thing, like for 6G we surely don't need voice support. But it's actually the operator exists. We need to have a native support of the voice for 6G, because just the remaining that part is challenging. So I think they kind of need to work together. Yeah.
Good. Yeah, so we can move to the third question. In designing 6G systems where AI tasks are tightly integrated with communication, should system architectures be primarily guided by computation demands, for example, for distributed learning or inference, or by communication constraints, for example, latency, bandwidth, etc. So what are the fundamental trade-offs? I guess this represents the fundamental trade-off between communication-first design or computation-first design.
So let me take a quick attack on it and move away from the previous topic. So to me, it's a very broad question, and I think we are at the very early stages. And by necessity, as AI starts being deployed in highly successful, let's not use the killer app, but that's going in that direction, it's going to depend very much what you're trying to do. For instance, close to me, if what I'm doing is ask the AI to do a literature survey of a particular topic, I absolutely don't need the pipe to be anything more than a good pipe. I don't care about latency, whatever bit rate I get for text transfer is going to be trivial, yet the help I'm getting of saving my time in spending hours and hours of surfing the internet to find the right articles is extremely valuable. But that clearly to me is going to be provided by over-the-tops and with minimal or zero engagement from the service providers, whether we like it or not. As we move up to more and more demanding applications, I can envision into some more advanced future where perhaps I'm doing real-time interaction across cultures, across languages, playing music in a group setting, and then, of course, I can only do it if the physical layer is somehow engaged. Are we going to break the model? And again, for once, are we going to have this happy combination, synergistic of a physical layer optimization, cloud-provided services, and AI ML? Perhaps, but I think the first wave is going to be the low-hanging fruits of the pipe is still the pipe.
I agree with Reynaldo that this is kind of very broad questions. And I think this trade-off, basically, it really depends on the capabilities that you're looking for. For example, consider ultramassive MIMO, right? So in this case, you're going to get a very high spectral efficiency, but then the computational complexity is going to be huge. Take terahertz frequencies that people are talking about right now. We're going to have a very high bandwidth, which is very nice, but then the range is going to be pretty small. And therefore, perhaps we're going to need more edge devices and so on and so forth, or edge nodes. The question you ask about the computational, so basically communication and computation and communication, I think these are very important and what I call perhaps fundamental items. And one way for us to think about them independently, and that's why you ask maybe this trade-off, but in my view, perhaps we should think of them as kind of two fundamental elements that we should think of a joint optimization, perhaps joint design of computation and computation. I think this is happening right now. So there is a lot of work right now going into trying to do what we call, instead of looking at them as separate layers, but basically try to move into a joint design and optimization. And I think, to me, that will be something that we should be looking at.
I think I answered the second part of your question. What are the fundamental trade-offs? From operators' point of view, service providers' point of view, the most important aspect is the cost of the network, which I think is going terahertz or high frequency and big expenditure, capital costs, and etc., and management overhead of all these small cells. So let me just summarize. Cost is important, and part of that cost, energy cost, is important. And I remember when at the beginning of 5G, we were talking about the SON, self-organizing networks, and etc. One operator that we work with very closely said to me, Rahim, don't worry. We put more computing at the edge, at the base station to do this sort of thing. That's easy for us to do. But can we reduce the cost of the energy that we consume and optimize the spectrum that we have for more capacity and better reliability? So I would say these factors, cost, energy, and management of the system are the most important trade-off. I don't think computation demand is a big factor.
I think there's one more in addition to power, and that's storage. The ability to cache can make a big difference in different places also. Yeah.
Wait.
I think that depends. This depends on the. On one scenario, it depends on the user side or the base station side or edge side. So for as a user, so that it has the small device and limited by the power battery. So I think the priority may be given to the AI task for the communication, and it may transform, uplink the data, and also the small, the lightweight model parameter to the edge server. And at the other side, the base station side or edge side, so it may have the large power compared to the user side. It may give the priority to the computation specific priority, and then to calculate the model parameter and then perform the AI to the modulation or the field layer detection, etc., and or find the beam, and then deliver those weights or the parameter to the user side. So it depends on which side that's the device. So we may schedule the AI tasks.
Yeah. So for this trade-off, so now we show up with in the edge we have three entities. One is the basic computing or plumbing computing, and then we have the digital twin. That's additional computing. Extract the number. The data is from the RAN, from all the RAN operational radio. You come out with the twin, and then you have a service computing that may offload to the edge. So interaction between the digital twin and the service computing part, that could be a generic AI platform will do that. But then once you extend this AI computing to the basic pipe computing, that's where I have trouble, because this is not best energy efficient. We would rather to spend, because the energy is the cap, especially in the age of sight. So that is the fundamental limit. Then we have to shift more computing power for the intelligent computing to gain more service advantage, rather than to compute what we know well already, especially the phi modulation decoding with the AI computing.
Good. So we move to the final question for this panel. How can edge devices continuously update or adapt their models over time without relying on cloud-based retraining? You sure? Please.
One word, sensing. Continuously sensing the environment and understand what is going on, as well as learning about the user profile, what the interests are. We talked about personal services yesterday, as well as sensing. I think this continuous information provided and we can gather so far is being neglected. Now we can utilize those for this learning capability over the time, and gradually learning about the user interest as well as the environment is operating. And I think that is important. That's why we say one of the reasons that sensing is important factor in integrated communication setting is to help the communication and help with a better utilization of the resources.
So continuously update their model, that might be possible. But continuously updating the inference, I see, is impossible. Because, so what you will be doing, at least that's my vision, is not to lose your license, because you need a certification. If you're like an autonomous vehicle, and you continuously adapt and change your inference depending upon your sensing information or whatever you've been seeing, you're dead, right? Because, I mean, nobody's going to sign off any insurance contract on this kind of a car. So that's why what really needs to be understood is that, or if you do the same thing for, I mean, if you look at today, I work in medical devices also. In medical devices, if they update a software patch, put in a software patch in a CT scanner, they lose the license to operate that CT scanner. They have to go through the whole recertification, which takes another 10 years. So we have to get to a model where we do this continuous update on a digital twin and then do regression testing somewhere overnight in backgrounds, whatever, once a month. And by doing regression testing on these new models, then also get something that is fully approved and certified and being able to put into the system. So I just want to make sure that we understand continuously update is not something where it's then continuously applied to the inference model, but it's done against a digital twin. That's at least my point of view.
Sure. And then
Don't forget, I mean, Tesla, when it came out, the way you drive, the path that you drive from your work to home and etc., it learned about the road potholes and where the bumps are and etc. And always, next time you drive that, it gives you a recommendation. So continuous learning is already been there. And it doesn't violate anybody's insurance policy.
No, that's not.
It's just recommendation.
That's not continuous learning. That's using the same inference engine, just adding some data points that there's a pothole. I'm talking about really updating the inference model.
So I think the point that Wen Tong made is very important, and we shouldn't lose sight of it. Tremendous effort has been done by the vendors in collaboration with service providers in reducing the power need at the sites. going from needed a hut with air conditioning to requirements nowadays that the entire hardware can be brought in a backpack and any surface can be touched by an operator without getting burnt. If the updates or whatever it is, fancy new applications at the edge are going to break that and requiring incredible amount of power consumption and heat dissipation and air conditioning, it's out of the question. It's not going to happen.
I wanted to point out a technique in which you might be able to continuously adapt the models, which is something that we've done with deep neural networks, is break them into pieces, and including optimizations such as the quantization and whatever, and implement dynamically according to the context and constraints the entire model by connecting the pieces, okay? And that gives you a lot of flexibility in terms of how you implement it, gives you the ability to adapt to the environment, and through something like the digital twins he was talking about, you can, before you do that, work the trade-offs in terms of accuracy, power, and so forth. So that's a way. And sorry, go ahead.
Just a quick follow-up with ours. I was in the last GlobalCon, but this is not my idea. It was the Saturn's group. So what they say, they find out is about 40% of a deep learning neural network is actually no connection. So what is a continuous learning is that you keep this as a backbone model. When you have a new data coming, don't touch this already trained coefficients, but use the empty, unused portion to train the network and gradually learning. That's the continuous side. But what Gerhard has a point is that this model eventually have to be certified. Then that approach will make the regression test much more smaller because you just need to check the incremental part.
Yeah, I actually have a question to Gerhard. So you bring up an interesting point in that, let's say, if we keep the model same, you say we certify it. As long as we don't touch the model, you consider that that is okay. But the question is that, as one just mentioned, let's say, even I use the same model, but I feed them more data, the behavior is different. So how can we guarantee my certified behavior is still consistent with this new behavior with added data? I mean, assuming added data, if it's going to the better direction, is okay, but it could getting worse. It's because we all experience if we ask a question to GPT, next time you ask another same questions, right? You will get a different answer. He will take your input, like he's trying to cater your flavors. So therefore, how can we actually do the certification? Maybe we need a new way of certification rather than,
I think we need a new way of certification. We have two different parts. So once we have the inference coefficients, which means the actual AI algorithm stays the same. The other thing is the database of like potholes or people's reactions or whatever, which is then different again. So you have to make sure that that part that really determines the reaction is fully certified, versus that you don't say, I have to already also make sure that the database of every single physical spot on planet Earth has to be part of the certification, but that can vary because, roads are going to be blocked, things are going to be changing. So there's a difference between the physical behavior of a vehicle, robot, whatever all, and the database in terms of a map or whatever that it uses to work on. And that has to be done during the certification so that you can change the map without changing the inference model itself.
John.
So a few years ago, I used to give this talk. I thought it was funny. Nobody ever laughed on it. I call it AIR, A-I-R, Artificially Intelligent Regulator. And as we talk about, when you're talking about the healthcare thing, Gerhard, that's a regulator of some type that's certifying. And then we can look at 5G. We have standards, and then there are groups like the Wi-Fi Alliance, which is really a certification group for the IEEE 802.11 standards. You know, when are we going to cross this threshold where I used to put up a picture when I did this artificial intelligence, which had the FCC 5 commissioners, and then I put a robot's head on the chairman's face instead of, you know, whoever the chairman was, put the robot there. But it seems like that's the only way to avoid the 10 years and so forth. On the other hand, I have the same experience with ChatGPT, especially when it's kind of something fairly new. It's trying to please me, and it gets worse and worse on each subsequent question with the hallucinations, and eventually you give up and say, it's totally off base. I can't use this anymore right now. I have to restart with what I was doing. If we can get to that stage, and I think we probably do, at what point, you know, do we solve these problems? And the information will have to flow back from the devices. I don't know that we have to update them that often. They can do a lot locally, but there has to be a process where their data goes back for some kind of certification. But it would be really good if that could be more reliable than humans and done much more quickly. And it'd be a great maybe research for the future if we could get to that point, because nobody wants to wait 10 years for the latest technique to be available. You might die if you've got a disease, you know, by the time that they approve the treatment for it. So that's obviously shortening that cycle, but without the hallucinations and the negative effects is the big deal. It seems like that may be the biggest challenge we see in communications in the next 20 years is to try to get that.
Just to discuss this point, if we are further go down from the bare naked, the neural network model, the so-called agent. So in the agent, there is one critical component is verification. The agent concept is doesn't matter which model comes through, you have to pass my certification, verification gateway. So that verification can be formal verification if your code there's no logic bug, or some even the regulator verification. All kinds of a document, legal document can put it. This is a RAG, so you have to go through this gatekeeper in order finally to confirm that you can take action. So that's the latest so-called agent model. So in terms of interface, these 5 months was very big. It was called MCP, so the Model Context Protocol. So that allow you can plug in any open source model, use any open source tool, use different people memory, or the memory in the cloud I don't want to share. That's the memory access. And then they make an entire flow output to take action. But anyway, there will be a gatekeeper.
You said it's called NCP?
MCP.
What's the M?
Model Context Protocol. So these are the 5 months that's already become de facto. So a month ago, Google announced agent-to-agent protocol. So these are they form in that way. Not, I don't think nobody talking bare naked model become next layer, become an agent, because the reasoning stuff is already being done by O3 and O1 and O3. So that's the progress that they make. But with that reg stuff, you can put any regulatory FCC 10 years or some even 5 years, or even the software is in the seconds that generated, and then you run different mathematical prover, formal prover, government prover, and do that you have to do. So this is a sandbox work. You have to spend a lot of computing in order to get that flexibility.
So I'm going to try to just briefly answer. So I'm trying to, one potential solution, how we can do that. So here we're talking about edge devices. So one way to do that is we can actually take advantage or leverage basically when you have large data set and that have already been trained. So you can basically allow adapting perhaps the pre-trained models in order to basically to new local data at the edge devices. So in a way, this is kind of typically now we use what we refer to as fine tuning. Perhaps it's another way of calling it transfer learning. And so I think this can work pretty well for edge devices. And so I think in April, we had a paper in the Transaction on Wireless where basically we've looked at the large data set that we've used our foundation models that are already pre-trained, and then we use that in order to apply that on edge devices by using this idea of fine-tuning. And we found out that it actually works pretty well.
Yeah, I think we should really touch base with our roots, our core, our main mission as service providers and equipment vendors. And I think the AI at the edge, at least initially, primarily, and with great benefit, is going to be optimizing the physical layer. And physical layer is a challenge, but there is a lot of compute as the massive MIMO gets more and more antennas, beamforming, computation, etc. But as the gains, it's a current debate as how much gains are you going to get from AI in that space, and that work is progressing very nicely. But the good thing about it is true to our historical mission, and it does not involve the over-the-tops in any way, back to my early point. And then there is low-hanging fruit that's going to be happening right above in layer 2, layer 3, when you combine resource allocation with scheduling, but it's all about making the physical layer and the transport faster, better, higher bandwidth, higher bit rate. All of that is going to happen without asking the permission of or the subsidy of over-the-tops. And I think that's going to happen for the foreseeable time and will be indeed true AI at the edge.
Me? Oh, I'm sorry.
I wanted to give you the chance to talk first. No, but I mean, anybody that has worked in handoff optimizations, example, just to allude on further on what Rinaldo has touched, knows that with massive MIMO, beams penciling all over the place, and these kind of things, it's become more and more complex. And it's very much situation dependent. So to have situation-aware handoff happening already, we have these nearest neighbor lists, sense 2G, so that you only hand off in the next nearest neighbor, and these kind of things. That's without any AI. But now think of it that with all the correlation that can be learned over time in the cellular network, if we talk about just the physical layer ones, and understanding how to optimize that part, that's a huge potential on its own. Because, I mean, we've tried to use, 20 years ago, we used force field models and whatever, all kinds of things, which is sort of low-level AI, to optimize these massive MIMO handoff protocols. And then we have different service layers sitting on top. We have best effort layers, we have voice calls, we have low latency layers, all kinds of different KPIs that have to be handled at the same time. So you have this whole behemoth of different service layers, behemoth of different kind of physical situations, and then to have something which we're going to see more and more so that we know very well the geolocation of one of the terminals and therefore know the radio environment right there in that area and can have learned this through correlation, fancy correlation as AI, to then be able to optimize the networks and network capacity is going to be huge for sure.
Yeah, I think I'm okay with this. We continue to optimize this network. That's for sure. That's a given. We have to do it. The only problem is that even we do that, we still run into the same problem as today. You still get pipe, you don't get any revenue increase. Right? So that's why I think it is if we are going to do this AI for the communication anyway, we definitely need to explore how we can get the additional service. If we just focus on the communication part, yes, we provide more capacity, but still, you give up all the revenue. So that is a problem.
I totally agree.
Yeah.
And for me, I have a slide where I always say, look guys, I mean, we learn these kind of things in the ISM world first, and then we move to cellular, right? So we've done OFDM first in Wi-Fi, then in cellular. We've done spread spectrum first in Wi-Fi, then in cellular. We've done LDPC codes first in Wi-Fi, then in cellular. We did millimeter wave first in Wi-Fi, it failed miserably. Then we did it in cellular, it failed miserably.
I'd say the fixed line was before the Wi-Fi and all that.
Yeah, but still. But if when I'm talking about going wireless, I'm talking about going wireless. Yeah. So if we now think of paying what you were saying, I really think we have to go into understanding mobile private networks and campus networks and Wi-Fi networks and industrial systems, and trying to see where are those applications sitting there, and we have to spend the time and the effort. I've been trying to convince the red operator in Germany to put some effort in there. They don't like listening to me on that respect. Other respects, yes, but on that respect, not. Because I say, you're going to have to invest $1 million, $2 million, $10 million with that kind of customer, trying to really understand how can you add value to the table such that the customer is then willing to say, okay, now we got it. Because this is it's a very tough rock climb that we have to head for. It's not going to happen automatically. What is going to happen automatically is that we're going to have a lot of AI compute sitting in the edge of the RAN. That is going to happen automatically just for the reasons we were talking about before. But now, how to monetize this for additional services, for additional benefits that then a customer is going to be willing to pay for. That is where we're going to just have to go into the sandbox, shovel the sand and dirt, and start learning by doing. I truly believe. I don't have any other proposition there.
Yeah, I think, Gerhard, I think the EMBB type of service for additional value is, I think, is over. It's not much of a hope. So the AI is probably the only opportunity right now for the edge computing and the added service. The edge computing is the first level to cross, but then the added value, that's where it's a big difficult problem and a challenge as well. So that physical environment or the sensing, all this bring up, this is one avenue to reach that, because everything, once you get in that AI, is data driven. So who has the data, or what the data will create additional value? That is the chance. And the other one is because you have an AI platform, so all the software programming is over. Anybody can create any app now. So that brings the OTT and the operator, the staff at the equal level of playground, because before today, operator has zero software development, software workforce in-house. So any new service has to be, you have to rely on the OTT to deliver the app. So now this level is further, most people in industry are talking about end of this year there will be no programming needed by humans. So at least the new software.
So I think we touched a raw nerve here, and maybe it's not really related to AI at the edge, but it's an existentialist question. So how do service providers, equipment vendors grow revenue? If you put it at a very high level like that, surely we can try and continue to squeeze revenue out of the over-the-tops. But historically, that has proven very, very difficult to do. And you could look at today. You don't need to be futuristic, right? Today, the user spends in access a certain amount of money, while on apps and services like video streaming, it's almost as much money as that or more. Now, why is it, or is it realistic to say, oh, from now on, you aren't going to have to take X% of your video streaming membership and give it to the service provider? Well, it's being very honorable efforts in that direction, but I think so far they've been failing miserably. I want to pivot to the positive examples, the inspiring and perhaps future growth examples. Let's, in addition to attempt to going up into the apps space and video streaming, what about going laterally and leveraging the fantastic network capabilities, especially I'm talking about private networks. So this is already proving successful. Of course, there is the curse of big numbers. If a company is making 10 billion, 20 billion, and then you are selling equipment order, 1 billion, it looks very small. It looks like it's hard to move the needle. But you should really, if you are talking about futuristic, we should look at the trends. So the growth rate on private networks is very appealing, very positive, very encouraging. Now, everything comes with a caveat. If it was easy, it would have been done already. So if we are successful, totally resonate with Gerhard here, if you want to go and sell a private network into a chemical compound, then you really need to roll up your sleeves and you need to understand the needs of that particular vertical. You cannot just try to sell it as a box through a third party and ignore it. It's not going to succeed. And there is incumbents. Like Wi-Fi is doing terrific with industrial grade networks. It's got its limitations, and that's where 5G in a small package, small cells, but with the reliability, with all the added baggage and toolkits that 3GPP networks have, can put a tremendous competition if we get the price points right and we get the customer service right and ongoing service right. So, and this is already being very, very successful in various verticals. Medical is one, many others, campus networks, etc. So instead of trying to continue go back up, and there is a reason, right? Why people grow banks is because that's where the money is. Why is a focus on the over the tops? That's because there is a lot of money over there. But they have proven very refractory to pay a tax to the transport. And so I'd say, in addition to continue efforts in that direction now in the AI area, why don't we use AI to simplify the deployment into verticals?
Yes, so that's, I guess that's the business reality. The diffusion of the technology, the fastest way is the 2C market and with the economic scale. So that's where the problem is more difficult than to do the vertical. Vertical is not technical problem, it's the, yeah.
Yeah, that's great. We are just on time to finish the discussion of this panel. So we are going to have a 20-minute break. So we are going to come back at 10:45 for the final panels. Thank you.